Good evening. Hello, my friends. How are you? Well, last class we have discussed basic concept of inverse trigonometric functions. From last class, we get the inverse first trigonometric function, that is sine function relates from r to -1 and +1, and cos function relations between r2 -1 and +1, and tan function relates r minus x such that x is equal to twice n plus 1 into pi by 2, where n belongs to z to r. Similarly, cot function, sec function, and cosec functions relations, that where r is a domain, or that is the range. From these, this is the natural domain and range. To get inverse of sine, cos, tan, that is the inverse of all trigonometric functions, there are some restrictions. There is some restriction to make it invertible. That is, to make it 1, 1 and on 2, then we get inverse function. So we get sine inverse relates forms -1 to 1, relates from -pi by 2 to +pi by 2. Similarly, cos inverse also relates -1 to 1 to 0 to pi. That is the inverse. This is comes to do here, and this the rest with restriction, this become this. The restriction means that portion only. That portion is the range. Similarly, cos inverse, in case of cos inverse, this portion is the range. That is the restrictions. We make the restrictions only these portions. The range is this portion, then trigonometric function has a inverse. Now today we are going to discuss the properties of inverse trigonometric functions. For this, we have divided the functions in the inverse function. There are 6 inverse functions: sine inverse, cosec inverse, tan inverse, cos inverse, sec inverse, and cot inverse. We divide 2 groups. In one group, we take sine inverse x, cosec inverse x, tan inverse x. That is a one group. Another group, we take cos inverse x, sec inverse x, and cot inverse x. That is the another group. Due to some symmetry, there is a word in the mathematics, symmetry. There is a symmetry. There are rules and their properties has some symmetry. That's why we have to divide the inverse trigonometric functions in 2 groups. One group has a sine inverse, cosec inverse, tan inverse. In another group, we take cos inverse, sec inverse, and cot inverse. Due to some similar properties. After this, we are going to discuss some preliminary rules. That is the sine of sine inverse x is equal to always x, where x belongs to their range -1 and +1. That is known as a principal value branch or range of sine inverse. And also sine inverse sine theta is always equal to theta, where theta belongs to -pi by 2 to +pi by 2. And similarly, we get cos inverse x is equal to always x, where x belongs to -1 to +1. And cos inverse cos theta is equal to theta, where theta belongs to 0 to pi in a closed interval. That is the preliminary. Similarly, we can find tan, cot, sec and cosec. Similar relation we get. Now we are going to discuss properties of inverse trigonometric functions. In this case, number 1, we get, that is the relations like this. We have in trigonometry, we get sin theta is equal to 1 by cosec theta. Then the cos theta is equal to 1 by sec theta. Tan theta is equal to 1 by cot theta, and so on. In case of inverse function also, we get like similar property. Number A, sin inverse 1 by x is equal to cosec inverse x, where x is greater than equal to 1 or x is less than equal to -1. Similarly, cos inverse 1 by x equal to sec inverse x, where x is greater than equal to 1 or x is less than equal to -1. In the same way, we get tan inverse 1 by x equal to cot inverse x, where x is greater than 0. That is the 3 preliminary rules. That is the 3 preliminary properties of inverse trigonometric function. That is the one groups. That is in another groups. That is the symmetry. Similarly, in this case, we also find like this: cosec inverse 1 by x is equal to sin inverse x. That is the ulta. Similarly, sec inverse 1 by x is equal to, we get cos inverse x. And cot inverse 1 by x is equal to what? Tan inverse x. Like this. Like this. That is the properties. This is also trigonometric properties. This is also inverse trigonometric functions properties. There is a similarity. So it is very easy to remember. There is a tips. We relate this, then we get easily we can remember this. After this, we get another 3 properties. That is sin inverse minus x equal to minus sin inverse x, where x belongs to -1 and +1. Number B, tan inverse minus x equal to minus tan inverse x, where x belongs to real numbers. Number C, cosec inverse minus x is equal to minus cosec inverse x. That is in one group, where minus comes out from the bracket. Here also minus came out. Here also minus came out. That is the one group. That's the one similarity. In another similarity, we get these. In another group, and these are belongs. So in case cos inverse minus x, we get pi minus cos inverse x, where x belongs to -1 and +1. And B, sec inverse minus x equal to pi minus sec inverse x, where modulus x greater than equal to 1. Similarly, cot inverse minus x equal to pi minus cot inverse x, where x belongs to R. And that is the another group. Here minus came out. Here there is a pi and minus, same thing. This property related with trigonometry property. In trigonometry we get sine of minus theta is equal to what? Cos of minus theta is equal to what? All sine tan cos. গতিকে cos equal to cos theta. This equal to minus sin theta. Like this. This is, we can relate this also to remember these formulas. After this, we are going to next property. This property is very simple. Like this. Formula number 4, there are 3 formulas. That is sine inverse x plus cos inverse x is equal to pi by 2, where x belongs to minus 1 and plus 1. Similarly, tan inverse x plus cot inverse x is equal to pi by 2, where x belongs to R. And cosec inverse x plus sec inverse x is equal to pi by 2. Here, right side always pi by 2. One comes from one group, another comes other groups. One comes tan from one group, cot from another group, and one from another group come from another group. Then we have to add them, then we get pi by 2, pi by. All our answers are pi by 4. From this we can find another formula also, another relation like this. Like this. Suppose we get sine inverse x plus cos inverse x equal to what? Pi by 2. That is the property. If we interchange, then we got sine inverse x is equal to what? Pi by 2 minus cos inverse x. This is also we can use like this property. And from this property we can find this also another property. Both properties are same, but in case of this we can write sine inverse x. Similarly, in other 3 cases also we can find similar way. After this, we get another 2 formulas. That is number 5, tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy, where that is the condition. Very important thing. Very important condition. That is xy is always less than equal to 1. That means this is always positive. This is always positive. Similarly, another in case of minus, tan inverse x minus tan inverse y is equal to tan inverse x minus y divided by 1 plus xy, where xy is greater than minus 1. That is another 2 properties. Actually, these properties come from trigonometric function, where we have get already tan a plus b. There is a similar thing in trigonometry. This formula is equal to what? Tan a plus tan b divided by 1 minus tan a tan b. Like this. And in case minus, we get another formula in trigonometry which are found in class 11. This is equal to what? This is minus, tan a minus tan b divided by 1 plus tan a into tan b. That is, therefore we can say that this formula comes from this also. That is the tip to remember. Since we have already know this formula, so we can remember this formula, then we get these properties of inverse trigonometric functions. Similarly, we get another 3 formulas. Which are? This is a 10. In this side, that is in left hand side, we get twice tan inverse x, twice tan inverse x, twice tan inverse. In the right side, we get sine, cos, and tan. Suppose we get this result we want in sine form, then we can use this formula. And result can we get in cos form. If we want to cos, then we use this formula. Similarly, tan in tan forms. This formula 2 tan inverse x is equal to sine inverse twice x by 1 plus x square, or modulus x is less than equal to 1. Number B, 2 tan inverse x is equal to cos inverse 1 minus x square divided by 1 plus x square, where x is greater than equal to 0. Number C, twice tan inverse x is equal to tan inverse twice x divided by 1 minus x square. That is the T formula. Actually, there is a relation. We get a big relation which we can write in this way also. That is the very important formula. 2 tan inverse x is equal to sine form of, in sine form we get twice x by 1 plus x square is equal to, in cos form we get cos inverse 1 minus x square divided by 1 plus x square is equal to, in tan form, tan inverse twice x by 1 minus x square. That is the very, very important formula. So we can say it is a BBI. To remember this. If we remember only this formula, then we get this TR. Same thing. Sometimes we can use this equal to this also. Sometimes we use this equal to this also. Sometimes we use this equal to this equal. Sometimes we use this equal to this also. In this way, we can find many relations which can be useful for solving the many problems in exercise. Moreover, we can prove all these formulas by using trigonometry. We can prove this all formulas, all properties by using trigonometry, but in examination point of view, the proof is not necessary. But it is, remember, the proof is very important. I think you have to done like homework, the proof of the following. Next, we are going to example of NCERT textbook in exercise 2.2. Example part. Example 2.2, the example number 3. So that number 1, sine inverse twice x into root over 1 minus x square is equal to 2 sine inverse x, where minus 1 by root 2 less than equal to x less than 1 by root 2. To prove this, to show that, that is the solution part. For this, first we take let x is equal to sine theta. This implies sines come to in this side, then we get sine inverse x equal to theta. Now left hand side is given sine inverse twice x root over 1 minus x square. This equal to same sine inverse 2 like same. In place of x we can write x is equal to sine theta, so we have to write sine theta root over 1 minus x square. X means sine theta, that's why it becomes sine square theta. Next line, sine inverse into whole into 2 sine theta. From this we get 1 minus sine square theta is equal to what? Cos square theta. So under root cos square become cos theta. Then we get sine inverse within bracket twice sine theta cos theta, which is equal to this. This is the formula, is equal to sine twice theta. So in place of 2 sine theta cos theta, we can write sine twice theta. Now we get sine inverse sine twice theta. We have already given a formula or given a rules. Then we can use. Then good, we get twice theta. Then 2 same in theta, we get theta is equal to sine inverse x. Then we get sine inverse x. That is the proved. Is equal to what? Equal to right hand side. Okay, very simple. Next, we are going to example number 3, question number 2. Same question, in place of 2 cos inverse, here it is given 2 cos inverse x, and one condition also there. Same solution, in same way we can solve the second problem also. For this, we take x is equal to cos theta. This become cos inverse x equal to theta. Now we take left hand side is given sine inverse twice x root over 1 minus x square, sine inverse 2. In place of x we can write cos theta, root over 1 minus in place of x we have write cos square theta. After this sine inverse 2 same, cos theta same, under root we get root over 1 minus cos square theta is nothing but sine theta. So we have to write sine theta. Then we get sine inverse. This is become sine twice theta. That is the formula. So we can write in place of 2 sine theta cos theta, sine twice theta. After this we get twice theta by using inverse trigonometric properties. Become 2 theta. Then we replace theta by cos inverse x, then we get 2 cos inverse x. This equal to, this is the right hand sides. That is the simple questions. Very easy. All are very important. So using this we get solve these questions. Next, we are going to discuss example number 4. In question number 4, in example 4, we are asked to show that tan inverse half plus tan inverse 2 by 11 is equal to tan inverse 3 by 4. Very simple problems. For solve के लिए we have to use the like this formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by minus xy, where xy is less than equal to 1. For this we have check it. Xy less than equal to 1. Here x is equal to half and y is equal to 2 by 11. Then multiply, then we go to cancel, then 1 by 11, which is less equal to 1. So we can use this formula. Because xy satisfy this condition, so we can use this formula. That is the left hand side, tan inverse half plus tan inverse 2 by 11. This equal to, by this formula, tan inverse half plus 2 by 11 divided by 1 minus half into 2 by 11. This equal to tan inverse, after taking LCM of numerator and denominator, LCM are same, then we get 11 plus 4. Here also we get 2 into 11 is equal to 22 minus 1, 2 is equal to 2. After calculation we get 15 by 20. LCM goes out. Then we get tan inverse 15 by 20. After cancelling we get tan inverse 3 by 4, which is equal to right hand side. That is the problem. Very easy, very easy to remember, very easy to do. My dear friends, I again say I have to give him complete suggestions, complete tips how to solve the questions and how to solve the exercise, how to solve the JEE mains question papers and others questions also in inverse trigonometric chapters. Next we are going to discuss example number 5. Example 5. Example 5 is given x space tan inverse cos x divided by 1 minus sin x, where minus thrice pi by 2 less than x less than pi by 2 in the simplest form. To express this in a very simplest forms. For this, we write tan inverse cos x by 1 minus sin x equal to tan inverse. This cos x can be written as cos square x by 2 minus sin square x by 2. From where we get? That is the main things. From where this is comes. I have given in side, the right side. It is the sin cos twice theta. Cos twice theta is equal to what? Cos square theta minus sin square theta. Since there is a twice theta, so here comes theta. That is half of twice theta is equal to theta. Since here x, then here half of x. Using this formula, cos square x by 2 minus sin square x by 2, we can write cos x is equal to this by using this formula. Divided by, in place of 1, we can write 1 is equal to what? Cos square theta plus sin square theta. This is always equal. So we can write since x by 2, here we have to also write x by 2. That is sin square x by 2 plus cos square x by 2 plus sin square x by 2 is equal to what? 1 by this formula. Minus here sin x. What we have to use? We have to use this. Sin twice theta is equal to 2 sin theta cos theta. Since it here twice theta, here comes theta and theta. This is half of twice theta. So half of x is equal to x by 2, x by 2. So minus twice sin x by 2 cos x by 2. Next line, same tan inverse. This equal to what? A square minus b square. What we have applied? We have applied this. A square minus b square is equal to what? A plus b, a whole into a minus. Very simple formula. And divided by what? A square plus b square minus twice ab is equal to what? A plus b whole square. So we have to write a plus b whole square. Okay. Next line. Tan inverse. After cancelling cos x by 2 minus sin x by 2 here, cos x by 2 minus sin x by 2 square, that is 1 cancel goes to this also. Then we get only 1 is remain. Then we get cos x by 2 sin plus sin x by 2 here, cos x by 2 minus sin x by 2. Then we get this line. After this line, we apply some tips. Tips are this: we divide numerator and denominator by cos x by 2. Then we get cos x by 2 divided by cos x by 2, then it is 1. Sin x by 2 divided by cos x by 2, then it is tan x by 2. Here also cos x by 2 divided by cos x by 2, then it goes to 1. Minus sin x by 2 divided by cos x by 2, then sin by cos equal to tan x by 2. Okay, then we get tan inverse 1 plus tan x by 2 divided by 1 minus tan x by 2. This can be written as in this way. How we can write it? The tan inverse x, same. 1 in place of 1 we can write tan pi by 4, because tan pi by 4 equal to 1, plus same tan x by 2, same 1, same minus same. In place of, suppose we have considered there is a 1, then we can write tan pi by 4 and tan x by 2. This is the formula like this. Tan a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Like this, tan a plus tan b divided by 1 minus tan a tan b. So we can write this equal to this. So here we have to write tan a plus b, that is tan pi by 4 plus tan x by 2. Okay. Then we get tan inverse tan pi by 4 plus x by 2. Then after cancelling tan inverse and tan, that by using the formula, that is the preliminary formula which are given today in first time, then become x by 4 plus x pi by 4 plus x by 2, which is the simplest form. So we can solve this problem very easily. I think no, there is no any difficulty. If there is a difficulty, please tell me. Please comment me where you have to not understand the question. Very simple question. Examination point of view, this question is very important from board examination point of view, from CBSE examination point of view, or other examination point of view is a very important. Thank you. Next we are going to discuss example number 6. Okay, example number 6 is given. Write cot inverse 1 by root over x square minus 1 where x is greater than 1 in the simplest form. How can we write this in a very easy form or simplest forms? For this, we can take first, let theta is equal to sec theta. There is a one question. Why we take this? Because there is a formula 1 plus tan square theta is equal to sec square. That means sec square theta minus 1 is equal to tan square. That's why we have considered x is equal to sec theta. Okay. So we take x equal to sec theta. This implies root over x square minus 1, x is equal to sec square theta minus 1 is equal to tan square theta, under root it becomes tan theta. Also, since x is equal to sec theta, then we get sec inverse x is equal to theta. Okay. Now, therefore we can write cot inverse 1 by root over x square minus 1 is equal to cot inverse 1 by this equal to tan theta. So we have to write tan theta. 1 by tan theta is equal to cot theta. Then we get cot inverse cot theta, which is given is equal to theta. If we replace theta by sec inverse x, replace sec inverse x, which is the very simplest form. Okay, the very simple questions. Next, we are going to discuss the example number 7. In example number 7, from NCERT textbooks, given to prove that tan inverse x plus tan inverse twice x by 1 minus x square is equal to tan inverse thrice x minus x cube divided by 1 minus thrice x square. It is given in all the three functions in tan inverse forms. For this, we have taken x is equal to what? Tan theta. Then theta becomes tan inverse x. Okay, very simple. From the question, we take right hand side. Right hand side is equal to what? This. So we have to write tan inverse thrice x minus x cube divided by 1 minus thrice x square. Okay. Now, tan inverse sames. 3 sames. In place of x, we write x is equal to tan theta. Tan theta minus, in place of x cube, we write tan cube theta divided by 1, same 1, minus 3. Minus 3, in place of x, we have to write to tan. There is a square, therefore tan square theta. Okay. Then we get tan inverse. This equal to tan thrice theta. Why? Where we get this? We have already found the formula in class 11. Like this, tan thrice theta is equal to what? Tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This formula is like this. So we can write tan theta. Okay. After using this rules, we get tan theta. Then we replace theta by theta is equal to tan replaced by tan inverse x. We get 3 tan inverse x. After this 3 tan inverse x, we can write tan inverse x plus 2 tan inverse x. If we sum it, then we get 3 tan inverse x. Okay. Then tan inverse x same plus 2 tan inverse is nothing but it is a very important formula. VBI, which we have the name as VBI. So from VVI formula, we get tan inverse twice x divided by 1 minus x square equal to 2 tan inverse x. That is equal to left hand side. Okay. Thank you. Very easy. There is no any difficulties. Very distinct and very easy. There is no any difficulty steps in this problem. Okay. Thank you, my dear friends. Next, we are going to discuss. There is a one another example in the textbook. Question example number 8. Here it is given, find the value of cos within bracket sec inverse x plus cosec inverse x where x modulus x greater than equal to 1. Very easy questions. It's a 1 mark questions. It comes from multiple choice also. Multiple choice question. MCQ. In place of MCQ, this question will set. Given cos sec inverse x, cosec inverse x. We know sec inverse x plus cosec inverse x equal to what? Pi by 2, where modulus x is greater than equal to 1. So in place of this, we can write pi by 2. From the chart, we know cos pi by 2 is equal to 0. So we can write is equal to 0. So values of this equal to always 0. Since we know cos pi by 2 is equal to 0. Okay. That is the finishing part of the example of exercise 2.2. Now we are going to exercise 2.2. That is the question number 1. From 1 to 4, there are same questions. Prove the following. All 4 questions are we have to prove. Then the first question is given 3 sin inverse x equal to sin inverse thrice x minus 4 x cube, where x belongs to minus f and plus half in a closed interval. In solution के लिए we have to take sin inverse x is equal to theta. Okay, this equal to sin theta become x. In class 11, we know the formula like this. Sin theta is equal to 3 sin theta minus 4 sin cube theta. Actually, trigonometry is a nothing but is a one type of play of formulas. If we remember many formulas, then we can solve many problems. If we remember less formula, then we solve less problems. जितना फॉर्मूला याद करेगा इतना प्रॉब्लम सॉल्व करके लिए very easy होगा. So we have to know the 11th class formula. That is, we know sin theta is equal to 3 sin theta minus 4 sin cube theta. This implies sin theta is equal to, in place of sin theta, we write x, then become thrice x minus 4 sin cube theta. So in place of sin theta, we write x, so x cube. If we interchange sin, then thrice theta, sin inverse equal to thrice x minus 4x cube. In place of theta, we can write what? Sin inverse x, 3 sin inverse x equal to sin inverse thrice x minus 4x cube, where x belongs to given range. That is the very easy problem. And those students who remember this formula, they will do the problem very easily. Okay? So very important things to remember the formula. How to memorize the formula? You have to memorize the formula. If you apply the formula in solving the question, then automatically your formula will store your brains. Thank you. Next, we are going to discuss the question number 2. Question number 2 is the same. In place of sin inverse, here it is given all in cos inverse forms. That is 3 cos inverse x equal to cos inverse 4x cube minus thrice x, where x belongs to minus half and 1. To get the solutions, first we have to take cos inverse x is equal to theta. This equal to what? Cos theta is equal to x. Similarly, we know a formula which we have to get in the class 11th. याद करेगा कैसे formula निकल जाएगा. If we use the formula, then automatically formula निकलेगा. Cos theta is equal to what? 4 cos cube theta minus 3 cos theta. But in this question के लिए formula is given in this question also, like this. Those who are intelligent, they always write the formula from here also, like this. 4 in place of x, we have to write cos theta. That is, we know the formula cos theta is equal to 4 cos cube theta minus 3 cos theta. Okay. Next, this implies cos theta is equal to 4 in place of cos theta. We can write x. So x cube minus 3 in place of cos theta, we write x. Therefore, it is a thrice x. If we change the side of the cos, then cos become inverse. That is, thrice theta is equal to cos inverse 4x cube minus thrice x. In place of theta, we can replace what? Theta replaced by cos inverse x. Then these are same. Then we get 3 cos inverse x equal to cos inverse 4x cube minus thrice x, where x belongs to half and 1. This is the conclusion. Very simple problem. Both problems are same. Only use करेगा how we can use the formula. That is the main thing. What formula we have to use this problem. That is the main criteria. That is the main thing. You have to remember formula. You have to memorize formula. Okay. Next, we are going to discuss question number 3 in exercise in from NCERT textbook. Here, question number 3 is given to prove that the tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse half. To solve के लिए we have to take left hand side. Left hand side is given tan inverse 2 by 11 plus tan inverse 7 by 24. Okay. For this, what formula we have to use? From the question, we have to remember that is the 10 formula to use. For this, there is a one question. What questions? What conditions? That means xy is always less than 1. Now we have to check it. Here x is equal to 2 by 11 and y equal to what? 7 by 24. After multiplying, we get 7 by 134, which is less than 1. Why? Numerator is less than denominator. So it is always less than 1. So we can use this formula because the condition satisfied. So we can use this formula, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. That means we have to use this formula. Okay. For this, we have to use this formula, that is tan inverse x plus y divided by 1 minus xy. After calculating or taking LCM of 11 and 24, here also 11 and 24, both LCM are same, numerator in case of numerator and in case of denominator, so LCM goes out. After calculation, we get 48 plus 77, and denominator we get 11, 24 is 264 minus 27 is 14. After calculating, we get tan inverse 125 divided by 250. And after cancelling this, we get tan inverse half, which is equal to right hand side. Okay. Very simple questions. Only you have to check it. Condition is satisfied or not. If condition is satisfied, then you can use this formula. Okay. Next, we are going to next questions. That is the question number 4 to prove this problem. The problem is given. Same problem in tan form. There is only difference is there is a 2 before tan inverse. That is the 2 tan inverse half plus tan inverse 1 by 7 is equal to tan inverse 31 by 17. Now, how we can solve this problem? Remember, how we can solve this problem, what formula we have to use, because there is a 2. For this, how to omit these 2. For this, there is a formula. 2 tan inverse x like this. 2 tan inverse x is equal to what? 2 tan inverse equal to what? Tan inverse twice x by 1 minus x square. So first step, we have to use this formula. That is 2 tan inverse x half plus tan inverse 1 by 7. That is the left hand side. For this case, we have to use this formula. That is 2 tan inverse twice x divided by 1 minus x square. Half square means 1 by 4. Plus this are same. Okay. Next, tan inverse 2 to cancel goes to 1. Then after calculating 1 minus 1 by 4, it becomes t by 4 plus tan inverse 1 by 7. Next step, tan inverse is become 4 by 3 plus tan inverse 1 by 7. Okay, that is, we get this question. Now we have to check tan inverse x plus tan inverse y. The condition is satisfied or not. That is, the condition is this. Xy less than equal to 1. If we multiply this and this, then we get 4 by 21. That is 4 by 21 always. 4 by 3 into 1 by 7 is equal to 4 by 21, which is less than 1. That means this condition is satisfied. So we can use this formula. Okay. So we can use this formula, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. After calculating, that is a simple calculation, taking LCM of numerator and denominator, calcium become 37, LCM become 21 and 21 goes out. After calculation we get 28 plus 3, and here also we get 21 minus 4, this become tan inverse 31 by 17, who is equal to what? That is left hand side is equal to what? Right hand side. That is the solve of the simple question. Very easy. For solve के लिए this question we have to use 2 formulas, this and this, which satisfying this condition, which are found in class 12, which are given to this formula, this property. We can formula, or we can say it is a property. You can use these properties. This question very easy. Please comment me if there is any difficulty. Please tell me, and you have to write in this please tell me and I give the details, and I'll sure I have to give the proper way. I have to take all of you in a proper way how you develop your mathematical knowledge. Okay. Next class we have to discuss the next part of the exercise, that is from question number 5. Next class we have to start from exercise question number 5. तब के लिए बाय बाय, फिर मिलेंगे. गुड नाइट. थैंक यू.